Welcome to our tutorial about data types. First, let's answer a pretty fundamental question. Why should you even care which data type you're using? Well, let me give you an example. In the Start Date column, we specified the type of data as date time. We could have also used var_char as we did for the address column. However, this means that we can't control how the end user inputs the employee's start date into this column, and usually the more control we can maintain over the format, the better. Let's say if we want to pull data and filter it by seniority or by how long an employee's been with the company, first we'd have to convert the data to the date-time format before running a comparison test. Setting a data type can also help prevent users from entering data that's not even valid. For example, if they make entries that we're simply unable to convert to the date-time format. Let's say we've specified the correct data type. Why at this point should we care about whether it's allowed a null value or not? That is, can the field be left empty without value? If we allow this field to be empty and we pull data from this table, it's possible that we'd miss some employees. Now, at the same time, we don't want to overly limit or constrict the type of data that the end user can input. It might be frustrating for the end user. A good example would be the zip code format. Logically, you think it might be best to set up this column with a numeric date type. But what if you've got employees in, for example, Canada or the UK, whose postal codes contain letters as well as numbers? Well, then your end user is not able to input the data, and this can lead to frustration as well as great inaccuracies in your data. This is just one simple example of an issue that could arise while you're designing your database. Let's look at another example. When we set up the employee ID column as our primary key, we use the integer data type. We specify that the value in this column should not be null. Now, even if I try to check the Allow Nulls box, I'm not able to. Visual Studio lets me know that the Allow Nulls property can't be set on a column which is part of the primary key. Here, we also specify how data is going to be entered in the column. We set the identity specification to yes, the identity increment to 1, and the identity seed to 1. Well, what do these settings mean anyway? This means that the values in subsequent rows will increment by values of 1, 10, 11, 12, 13, and so on. We can also enter a negative value if we need to. For example, we can enter the identity seed value at 100 and the identity increment value at -1. Then the entries will count backwards from 100, 100, 99, 98, and so on. If I change the identity increment, for example, to 10, the value will jump by tens, 10, 20, 30, and so on. Let's try it out in action. We'll use an increment of 2 and a seed of 10 and save. Right-click, show the table data, and let's right-click and copy the second row. Right-click and paste it. Let's paste it again. Obviously, we've got a problem here. When I mouse over, I see what the problem is. I'm able to copy and paste all the fields except for the primary key field. That's got to be unique. Let's right-click and execute SQL. Now let's right-click and delete this row. Confirm that we want to delete it by clicking yes. This row is now permanently deleted from our database. Let's make one more entry. Mick Smith. He also lives up the street on Main. October 10th, 2005 is his start date. Tab and making 23 an hour. Now the next record starts at 16. Basically, the primary key was deleted with the record that we deleted. If this doesn't make sense, don't worry about it for now. It's all going to become clear as we continue to practice working with databases throughout this course. For now, let's go back to our discussion of data types. The bit data type can be either 0 or 1. This is, of course, appropriate for columns whose values can be represented with a 0 or 1, yes or no, true or false, and so on. Now let's talk about the integer data type. It comes in 4 varieties. The tiny integer type represents only positive values from 0 to 255. Small integer, integer, and big integer represent values that are negative as well as positive. The currency data types are represented by small money and money. Both currency types give you 4 digits to the right of the decimal point. The small money currency value ranges from negative 200,000 to approximately 200,000. The money currency data type can handle much greater values, up to 922 trillion with a capital T. Next, we've got the date and time data type formats. These are represented by small date time and date time. They're not only different in the range of the dates that they represent, but also the resolution. Small date time has a 1-second accuracy, whereas the date time gives a 3.3 millisecond accuracy. Next, let's talk about character data types. We've got 3 character data types. Char represents a fixed length string from 1 to 8,000 characters. The var_char type represents a variable length string from 1 to 8,000 characters. The var_char max type can hold a very large body of text, up to 2 gigabytes in size. There's a few miscellaneous data types, for example, timestamp, unique identifiers, and cursor. Timestamp is a binary 8-digit number derived from the current time. This number is unique through the database. The unique identifier is a version of the timestamp. Instead of 16 characters like the timestamp, the unique identifier holds 32 characters. It's unique across all time zones. The cursor data type represents the results set returned from a procedure, for example. And this by no means is an exhaustive list of data types that can be used by an SQL database, but it's more than enough for our purposes for the time being. And this concludes our tutorial about data types.